If we were to sell like 155 people, would that be enough?
It would be, because they did say round. Yeah. Okay, C, we already did, and D, okay, this was C here that I just did. Let's go to D. The rate at which tickets were sold between 0 and 9 is modeled by that function. Based on this model, how many tickets were sold by 3 to the nearest whole number? Now they ask for the nearest whole. How do I set that up? The rate, okay, the rate at which tickets are sold. This is a rate, and we want to know how many were sold.
The integral from 0 to 3 of R of dt.
That's it. It's 3 o'clock. When did it start at noon?
It's 0.
It is 0.
Yeah.
I couldn't find it all of a sudden. Okay, so this is D. It's the integral from 0 to 3 of R of t dt. And you could throw that in a calculator and come up with the answer, and we're just going to look at the math. Here it is, 972.784. 972. Okay, now they did say round to the nearest unit. Why would that be? What are the units that go with this? So it's going to be 973 tickets. There we go. Yeah.
I had a question because I know like when we round people line or whatever we round up, but like when we talk about like tickets like people and stuff like that, should we round up? Because like they always said like,
I know, I just go with the
Just go with
0.5 and
round up.
above rule. Let's go with that. I think we're safest. Let me see what they did. Yeah, they rounded it up too. Okay. All right. I hope I didn't rush this too much, but you guys can see how they ask that question now. It's rare that they ask for an average value just by itself. They have it mixed in with some other things, and it's part of the question. So I just wanted to show you that. I don't think it's hard. The only hard thing is memorizing the formula for me. So I'm going to give you all that summary of concepts is going to have all the formulas you need to know for the year. So you can go back and study that for the test. I'm hoping it's kind of in your head anyway. So, okay, now today has a new topic. And I apologize for pushing you so much, but we're so close to the end. And I know for sure they ask one free response question for this every year. Now, do you remember when we first started definite integrals? Do you remember that we had 2 applications? And one of them was if you're given a velocity and you can find the area under the curve, you can tell how much distance was traveled. Do you remember the other one? Yeah, finding the volume of a weird shape. They always dedicate a question to this, always. So, and if it's not a free response, it'll be on the multiple choice, but it's, in the last 20 years it's been on there. Watch them not have it on there, but I know they will. So we're going to find volumes of weird shapes like this. In order to find the volume of the weird shape, I've got to start with this section that finds area between 2 curves. So, and then it'll lead to this, the next section, so we'll probably do that Tuesday or Wednesday. So we're on section 6.1, and it says more about areas. So it's kind of a nice review. Do you remember this kind of question from old days? It says, I'm asking you, how do you find the area of the region? Now, I'm asking this a little bit different to kind of lend itself to that weird volume stuff. But it says, how do you find the area of the region bounded above by f of x, that's this curve, below by the x-axis, that's here, and to the left by x equals 1, and the right by x equals b. Now, this is not a trick question. How do you find that area? Yeah. So it's going to be the area is going to be the integral from a to b of, yeah, there you go. That's exactly right. So that's just area from between one curve and the x-axis. What about if I have 2 of them like this? Now, I'm going to put little things, I have to make sure they cover this. The f and g have to be continuous, but that's always true for everything on it. But I'm now going to say that f has to be bigger than g. So I made f up here and g down here. And what I'd like to find is the area between those 2. I bet you could figure this out without even saying it. I mean, what's your gut feeling?
Find the area of f of x and the area of g of
exactly what it is. You find the area of f of x between this curve and the x-axis, area g of x, and subtract them. Now, that's it. Well, I'm gonna show you a little bit of the theory behind it because it's gonna help when we go to find this volume of a weird shape. So here's how I think about this. Do you remember when we started with area, remember how we formed all those rectangles that we built up? So I'm gonna think of it in terms of those rectangles again. So I'm gonna build a whole series of rectangles, but these rectangles are gonna go, I'm gonna go like this. I'm just gonna do a middle sum. Now, I'm just gonna put one of them in here, and it looks like this. Now, there really should be lots of them in there, so I'll have them all lined up all the way across here. Do you see how I just put it from the bottom to the top like this, the lower curve to the upper curve? Now, here's what I'll do is I'm just gonna first find the area of one rectangle, then I'm gonna find an approximate area of the region, and then I'm gonna find the exact area of the region. And I'm just going through the theory of it because, like I said, it lends itself really well to this volume thing. Okay, now, what would be the area of one rectangle? Okay, let me go down here. I'm just gonna call this x sub, I don't know what to call I. I'll call it that. Okay, and I'll call this width of this change in x. Okay, so what is the area of one of those rectangles? F of x sub I. You guys okay on that? Base times height? I think I'll switch them around, and I think you know why I'm gonna do this. Okay, there's the area of one rectangle. Now, I'm gonna have a bunch of
But that's not the area.
Yeah, because there's-
Oh.
X minus 2.
I'm going too fast, tell me again. Let me fix it, I'm going too fast. That would be minus, thank you. Okay,
Because that little bottom piece
Could
right
you factor out the delta
do
X?
you want to? How about if I factor it out and put it at the end? Thank you so much. Okay, times changing x. Does that make sense? You see where this is leading, I'm sure. What's the approximate area of the region? Well, this is one rectangle. I'm gonna have to add them all up, sum them all up. So what symbol would I use to sum up? Okay, so there it is. This is just one rectangle. This is the whole region. Oops, I can put it on. Okay, so we're gonna sum these up, and we're gonna say I starts with one rectangle to as many as I choose of this thing here. This is height times base. Okay, now, how do I get a more exact area? Before you do that, the limit is, yeah, the number of rectangles. We want to put more and more rectangles in there because it'll be more exact. So to get the exact area, it's going to be the limit is the number of rectangles goes to infinity of the sum of all those rectangles. Now, here's your friend, here's your buddy.
Here's your pal.
Yeah, here's your pal, it's Riemann. Riemann's the guy that put this all together, and Riemann said, instead of doing the limit of this, we can just do this. It's the limit, the integral from a to b of f of x, that's the upper curve, minus the lower curve, dx. And that's really what you guys said in the beginning. It's a gut feeling. So, that's pretty easy really to do. As long as f is above g the whole time, you can